Hey everyone, this is Reshma from Edureka, and in today's session we'll be learning what is OpenStack. Thank you all the attendees for joining today's session. So let's get started. So in this tutorial today we'll be learning what is cloud. I'll give you a brief introduction to cloud so that you can all be in the same page when in next topic I tell you what is OpenStack. After that we'll learn OpenStack in cloud and we'll see all the deployment models of OpenStack. After that we'll take a look at the OpenStack architecture and take a look at the different OpenStack components, which are nothing but the key services that OpenStack provides us. And finally we'll take a look at a use case so that we can understand how different people and different companies are using OpenStack in real life. So is the agenda clear to everyone? Okay, Anirudh says yes, Jason says yes. Thank you guys. So let us move on to our first topic and let me give you a brief introduction to cloud. Well, let us consider your current scenario. So you are using Google Mail for sending out emails. You are looking at videos, you're sharing videos on Facebook and YouTube. You're uploading your pictures on Google Drive and you're using Google Docs and spreadsheet to share your data among other people, and you are accessing all the services of this application in your mobile devices or desktop. But where are they actually in? Well, they're all in the cloud. You're accessing all the services, all this application and the data inside the application which is present in the cloud. But the question is that how do you actually create this cloud and what does this cloud actually have? Well, cloud computing is a type of internet-based computing. Well, because when you're accessing all those services and applications that are present in the cloud, you need to have an internet connection in your devices in order to access it. Now, where does all these applications and all this software lie? So how is this cloud created? Well, there is a bare metal server lying somewhere around the world. And what you do is that you just lay a virtualization layer on top of it, and then the server capacity is logically divided and the services and processing are shared on different devices for different people to access it and use it. And cloud computing provides you with broadly three kinds of services. Well, there are others as well, but they can be classified into broadly three categories. And the first one is the IaaS, which means Infrastructure as Service. There is the second one, which is known as PaaS or PaaS, which is known as Platform as Service, and the third one is SaaS or SaaS, which is known as Software as Service. Now let me tell you what are these in a brief way. The first one that we're going to learn is Infrastructure as Service. It means that it will provide you with the server and it will help you in virtualization, and after that part of installing some kind of operating system, laying out more instances or middleware, and then your application and data, that is all managed by you. So they will provide you with a virtualization where you can actually create up your infrastructure, lay out your instances, install operating systems inside them, and build up your infrastructure the way you like. The next one is Platform as Service. It means that it will just provide you with a platform in order to develop your applications. And finally, Software as Service is something like, you can say Gmail or Google Drive, where they give you a software that is in the cloud and you access it and you put your data into it. So this is a brief introduction to Infrastructure as Service, Platform as Service, and Software as Service. And let me tell you that today's topic, which is OpenStack, lies in the category of Infrastructure as Service. So this is a very brief introduction about cloud and how things are managed and stored in the cloud. So we'll be learning more about it. Okay, so Anirudh has a question. He is asking that isn't Infrastructure and Service and Platform as Service the same? Well, not exactly same, but they're quite similar, I will tell you that, because when you actually take up Infrastructure as Service, kind of end up having a platform only on which you can actually develop your applications. But the only difference is that in Platform as Service, you'll get let's say, operating system already. So that will be your platform. And when you have an infrastructure as service, it is going to be some of your choice, or this is something that will be under your control, that whatever operating system layer that you want to use in your infrastructure, you can set it up. When you have platform as service, you either have to buy a platform which is either, let's say, Linux or Windows, like that. But in the end, when you're building up your infrastructure or building up your application, you end up with the platform only when you're choosing infrastructure as service and platform as service. So I hope you have got your answer, Anirudh. Any more doubts? Okay, he says no doubts. Does anyone have any questions about cloud computing? So I'm going to move on to the next topic. And our next topic is, what is OpenStack? Well, in easy words, if you have to understand that, OpenStack is nothing but a kind of cloud service which falls under the category of infrastructure as service. What OpenStack does is that it gives you all the components in order to set up your cloud infrastructure, and it provides you with a set of tools and different components and services. So this is what OpenStack is, and OpenStack was created in 2010 by Rackspace, which is a very big cloud hosting company, and NASA. Yes, the NASA that sends people into space and the moon. So they created OpenStack in 2010, and let me tell you that the OpenStack community is actually huge. There are contributors like the giants in the tech world. They're all contributing to OpenStack, like IBM, VMware, Red Hat, Dell, HP, Cisco. Every one of them are in the OpenStack community, and they're contributing almost now and then in order to develop OpenStack. And the best part about OpenStack is that it is open source. You can get it for free, and you can modify anything that you need based upon the infrastructure that you want to create. So this is what we're going to learn today. I'm going to tell you all about OpenStack. And so this is just a brief introduction, and it is said that it is the future of the cloud computing because it's backed up by the huge tech giants in today's era. So any questions on this slide? Okay, no questions. So we'll move on and we'll see OpenStack in cloud. So what can you do with OpenStack? So like I already told you that it is an infrastructure as service kind of a cloud service, and you can actually add and run instances on it that you want to use. You can set up different kind of nodes for different purpose. Let's say you can actually build up your entire infrastructure. If you need any kind of instances in the development environment, you need a prod environment, a testing environment, and you want instances to run on each kind of environment, you can set it up all in OpenStack. And it also provides with a platform. Like, yes, Anirudh, I was telling you that even though it's called as infrastructure as service, at the end what you're going to avail is that it's going to give you a platform on which you can actually build up your own application and build up your infrastructure. So this is what you can do with OpenStack, and we'll be learning more about what we can actually deploy on the cloud and how can we make up a development environment in cloud. We'll see more about that later in this tutorial. So now let us move on and take a look at the cloud deployment models that you can have using OpenStack. Now there are 5 kind of deployment models that you can do with OpenStack. The first one is on-premises distribution. Now, as the name says, on-premises means that your data centers lie in your company. They're your servers, and then you can lay out a layer of OpenStack on top of your data centers. That is what it means. Then we've got an OpenStack-based public cloud and hosted OpenStack private cloud on the third. Well, let me tell you that with OpenStack, you can actually make your cloud infrastructure both public or private, or it may be even a hybrid cloud, which is some part of it is public and some part of it is private. Then we can see OpenStack as a service and appliance-based OpenStack. So let us take a look at them one by one. So the first one is the on-premises distribution. So what happens here is that your data centers lie in your own enterprise, in your own premises, And sometimes this is also known as on-prem. So this means the same thing. Prem means here premises. So your data centers are there, so you just download and install all the OpenStack services on your own to create that cloud infrastructure, and these resides in your internal network only. So this is basically a DIY, a do-it-yourself kind of cloud infrastructure. So you just have your data centers, you just download the software, install all the services, get them all running, and then you have your OpenStack cloud infrastructure. And the next model is an OpenStack-based public cloud. So what happens here is that a vendor provides a public cloud computing system based on the OpenStack project. So there is a cloud provider who is responsible for creating the cloud infrastructure and lay out all the services in them that you need. So you just go to that vendor, you ask for some services, and he gives you with all the services and all the data, and everything is stored in their servers, in the cloud provider servers. So this is a very good example of a public cloud is AWS, but if you wanted like, let's say, an OpenStack based, so you can just ask your cloud provider or your cloud vendor that what kind of OpenStack services do you actually require in order to lay out your application or for your project. So your cloud vendor will take care of it and provide you with all the services. The next one is a hosted OpenStack private cloud. Now, again, let's say that you've got some sensitive data that you want to remain, that you don't want it exposed in outside world, or you cannot rely on other people's servers to store your data. So you can just ask for a person, or you can ask a cloud vendor to lay out all the services for you in your internal network on your hardware, and all the management will be done by the cloud provider, the person who has actually laid out all the OpenStack services for you. So that will be done by them. It will be fully supported by them. They will only charge you for support for if anything goes wrong. Otherwise, everything else, the data and the application that you will be actually implementing them on the cloud infrastructure will be handled by you. So this is a hosted OpenStack private cloud. The next one is OpenStack-as-a-Service. So in this kind of deployment model, what happens is that your cloud provider will install OpenStack in their system. They will actually have all the services laid out in their own cloud. And if you want to avail any kind of services, let's say you want the compute service for your development of your application, so you can just ask for the service from your cloud vendor, which is giving out OpenStack services for you. So you'll be charged on the services that you avail. And finally, there is the last deployment model, which is the appliance-based OpenStack. So there is a cloud vendor which is called Nebula, and they are selling appliances, and appliances are the software that does not require an operating system to run. So this can be a service which is like pluggable service that you can avail when you actually buy that service, or that pluggable service which is known as appliance, and you can use it in your OpenStack deployment or your OpenStack cloud infrastructure that you have just set up. So these were the cloud deployment models. Any questions on that? Any question, guys? Okay, so let's move on to our next topic, which is the OpenStack architecture. So these are the components that actually make up the OpenStack architecture. So the first thing that you'll see when you're opening OpenStack is the dashboard. So this is a graphical user interface for you to use. So this is the dashboard, which is known as Horizon. And if you see this component here, this is called the Keystone, and it is used for authorization and authentication purpose. So every service is related to that. So if you ever want to avail any of these services, or you want to use any of these components, you have to get authorized and authenticated first. And that is done by this component over here, which is known as Keystone. And then there are the other layer of services. We have Nova, which is the compute domain. Then we have got Glance, which is the service for launching up instances. Then we've got Swift, which is the object storage service. The Neutron, the networking service. Cinder, the block storage service. Then we have got Heat, which is used for orchestration purpose, Celometer, which is used for metering and billing. So this is a part of actually the telemetry project of OpenStack, and Celometer here actually keeps on track of the instances that are up and how much services for how much time have you availed from OpenStack, and this actually keeps a meter running for every time you avail a service or every time an instance is active or running, and it is used for billing purpose. So these are the components that actually make up the OpenStack architecture. Well, now let us take a look at the OpenStack components. So these are the 9 components that actually explain you how OpenStack works, and the services that each component will provide us, we'll see that later in this tutorial. So let me just first give you a brief overview of all the OpenStack components. So first up we have Keystone. Now I was telling you that this is the authentication service of OpenStack. Now every service that you want to avail, whether it's an image service, computing, network, storage, or availing the dashboard, you need to get authenticated first, and this is taken care of by Keystone. So you can add a user and grant privileges using the Keystone. Then we've got Glance. Now Glance is actually the service that launches up instances. So this Glance has got all the disk images contained in them, different types of images, let it be Ubuntu, Linux, any kind of Linux, or Red Hat, or CentOS 7, CentOS 6, any versions. So this can be all stored in Glance, and then you can launch instances from the images that are present in Glance. Then we've got our computing domain, which is known as Nova. So when you launch an instance, you actually avail the Nova zone. So this is where all the computing and all the processing actually happens. Then we've got Neutron. So Neutron is the networking service of OpenStack, and Neutron is actually responsible for communication of the services with one another. Then we've got our storage services. The first is Swift and the other is Cinder. Well, Swift is the object storage component and Cinder is the block storage component. And these are all connected to a database or S3 storage, and where you can actually store all kinds of files. So in Swift it is stored as objects, and in Cinder you can store bulk, which is like a pluggable storage in your system. Then we've got the horizon. Now even though I'm explaining this component at the end, this is the first thing that we'll see when you're accessing OpenStack or when you're managing OpenStack. So the horizon is the dashboard with which every tenant or every other application user can actually launch up their own instances, manage their own instances, and get a brief overview of their cloud infrastructure at one place. Then we've got Celometer. Now Celometer is a part of the telemetry project of OpenStack. So the Celometer is used to check the uptime of all the instances, the kind of services that you have availed, and at the end it will produce a bill or log of all the services that you have availed and finally produce you the bill. And Heat is used for orchestration. Now you'll be using multiple applications on your OpenStack infrastructure, and for that you'll be running multiple services also. So you need a process to orchestrate all those services together in order to manage your application. And for that you can use Heat. So these are the OpenStack components. Okay, now Varun has a question. He asked that will we be seeing all these components as part of today's session? Yes, I will be telling you about all those except for Celometer and Heat. I will be actually telling you about the primary components or the primary services, which is up till Horizon. And Celometer and Heat will be covered up in the coming sessions. So this is just a brief introduction to OpenStack, and we'll have a brief demo of all these services. So for now, we'll be only explaining up to Horizon. Is that okay, Varun? Okay, he says yes. So now let us take a look at all the services and the components one by one. Now first up is Keystone. So what is Keystone? Keystone is an OpenStack service that provides API client authentication, service discovery, and distributed multi-tenant authorization by implementing OpenStack Identity API. Well, that is a very complex sentence, but I will explain it to you in a much easier way. Well, Keystone is an identity service used for authentication and authorization. Now, it's more of like a who are you and what do you want to do kind of a service. When you say authentication, it means a who are you thing. It will ask for your username and password so that you can log in, and after it actually knows who are you, the next thing you need to do or next thing you would want to do is to avail services. So this is the part when Keystone asks you what do you want to do. It will check if you have got all the privileges or the rights to make changes or available some kind of changes. So this is the purpose of Keystone. Now, Keystone works with a token services, catalog service, policy service, and assignment service. So with token service, it validates and manages tokens used for authenticating requests once a user's credentials have already been verified. So it is a session-based token management that Keystone uses. And then with catalog service, what happens is that it provides you with endpoint registry, which is used for endpoint discovery. Now, every other service in OpenStack is connected through endpoints. So with Keystone catalog service, you can actually avail and have an overview of all the endpoints, and you can check whether if the connection can be authorized or not for a specific user. And then we've got the policy service. Now what a policy service does is that it provides a rule-based authorization engine, and it is actually associated with a rule management interface. So there are some policies or some kind of maybe legal jurisdictions mentioned in rule management. So this policy service will check if you're authorized to do that, if you're not actually breaking any laws or any kind of policies, any kind of company policies when you are trying to avail something or use something in OpenStack. And then there is this assignment service. So what this assignment service does is that it provides data about roles. Now roles are nothing but these are levels of authorization that an end user can obtain. So if let's say a person has been given an authorization to use three services, and there is one more person who is authorized to use two services, so we can just define roles for each of them. Let's say the first one can be called role 3 service, then one can be called role 2 service, or any other role based. You can give them any names based on the role, and then you can actually manage the authorization rights among other people too by defining them with roles. So this is what Keystone is. So any questions on what is Keystone? Okay, no questions. So now let's move on and take a look at Glance. So like how OpenStack defines Glance is that the Glance project provides a service where users can upload and discover data assets that are meant to be used with other services. Now, you can think of Glance as a repository for images. So this Glance over here actually stores all the virtual disk images that you have added into OpenStack, and from there on, from these images which are stored in Glance, you can launch instances from there. And these instances can be used to set up your development environment for your application, for your testing environment, or prod, any purpose that you want it to. So what exactly is stored in Glance is that it only stores images and the metadata definitions of the images. And Glance actually uses a RESTful API that allows querying of virtual image metadata as well as retrieval of the actual image. So I'll show you and explain you the Glance architecture now so that you can understand it better. Okay, so this is the user, and let me tell you before I go ahead and explain is that in OpenStack, every service actually communicates using an API. So every communications that they do is through APIs. So they use both kind of APIs, northbound and southbound. So Glance also uses API to connect with the user and other services as well. So after the user, so this is the user who is using Glance, and it connects through a Glance API, and it goes to the Glance registry, which is connected to the Glance database, and the Glance database will store all the metadata definitions Okay, so Varun has a question. He asked that what is a north and southbound API? So you know that in a cloud infrastructure there are service layers, right, Varun? And then we use APIs to connect with each of the services. Okay, so let's say that I have a 3-tier layer. I'm just drawing a rough image. So this is the bottom layer over here, this is the middle layer, and this is the top layer. So if I want to connect from the top to bottom, I will use APIs that will connect it from top to bottom. Okay, so these are known as southbound APIs. Now, if I want my bottom tier service to connect with the top tier service, I'll use different APIs that will connect it from the bottom to the top. So these are northbound APIs. So southbound means from top to bottom and northbound means from bottom to top. So this is just a brief overview just to understand what northbound and southbound APIs are. So this is just used for connecting with different services of different tiers. So is that okay for you, Varun? Okay, he said, clear, thanks. Okay, so let's move on to our Glance architecture. So the Glance registry is connected with the Glance database, and the API also connects with different file system, with the object storage service also, which is Swift, and the S3, which is, and the relation and database also. So these storage systems will actually store the image in Glance. So the Glance registry will here contain each entry of images or whatever images that you have added into the Glance architecture. The metadata will be stored in Glance database. The images will be stored in Swift, S3, in different file systems. And from there on, if you want to launch images, you can launch it using Glance. So this is just a very simple layout of the Glance architecture. So any questions on that? Okay, so Anirudh asked, images means OS images, right? Yes, of course. I'm talking about like virtual disk images. I mean like Ubuntu images, Windows images, different CentOS, Red Hat, all those. Is that okay, Anirudh? And anyway, you got it right. That's the images that I'm talking about. So next up, we have got Nova. So Nova is the compute zone. So when you actually launch an instance from Glance, it is the Nova zone where all the computing takes place. So when you open the console of your instance, it is actually availed in the Nova compute zone. So this is where all the processing takes place in OpenStack. So Nova is built on a messaging architecture and all of its components can be run on several servers. So in Nova, every other microservice, or let's say every other component that is in Nova, actually communicates using message queuing system. So for that, we mostly use the RabbitMQ, which is a message queuing system, and we use it for Nova. So this is a brief architecture of the Nova. So the Nova has got APIs now, like every other service in OpenStack. I already told you that it computes with the other services using APIs. So this is the Nova API over here, and this is the message broker system. So this can be a middleware like RabbitMQ, which actually enables a message queuing system to communicate with each other component in Nova. So this is the Nova scheduler. So this is where all the scheduling or the queuing of different processes takes place. And when there is a queuing done, and if you want to actually like communicate with the compute domain, okay, so this process is going to come up in the compute or in the processing zone. So this is actually communicated using this message broker or the RabbitMQ. So the scheduler actually schedules jobs to be performed in the compute zone, and this is communicated via the message broker. And it is also connected with the network. So this network over here is mostly a Neutron API. I'll be telling you about Neutron just after this one, so you'll understand it better. So this is the Neutron part that it is connected to, and for that also it uses the message broker or the RabbitMQ in order to communicate with that service. So any questions on the Nova architecture? Okay, no questions. So now we have got Neutron. Now, Neutron is the networking component of OpenStack. And it is actually a standalone service in OpenStack, and it lies alongside all other services like I just told you, Nova, Glance, Keystone, the horizon, which is the dashboard. And like all those services, the deployment of Neutron involves deploying several processes on each host. Now, when you're using OpenStack, you're using like different hosts to install all the services. You are using a controller host, which is responsible for all the authentication and for managing all kind of services that are running on different hosts. You might have got different host for computing, and Neutron will be associated with all of them. Now, let me show you the architecture of Neutron. So this is how the networking is connected. So this is a gateway device, this is the access switch, which actually, and these are your host machines, you can say. They might be any kind of VM. So let's say that this one is a controller, these two are compute, and these are different services that are connected with each other. And Neutron actually relies on Keystone for authentication and authorization of all API requests. So Neutron, like I told you, that Keystone is responsible every time you want to access any kind of service, you have to go to Keystone, right? For getting authenticated and authorized to use anything, any service in OpenStack. And Neutron is responsible for actually connecting you with Keystone. So that is why Neutron completely relies on Keystone. It cannot actually connect you with any other service without going via Keystone, without getting authenticated first. And then with Nova, the relationship is something like, again, it interacts with API calls. And when you're using Horizon, which is the dashboard, I'll be showing you how to do that. So I'll just tell you the brief relationship of Neutron with Horizon. So with Horizon, it actually has got a basic integration with the Neutron API, and it allows all the users, which are known as tenants, to create networks by themselves by creating subnets. And you can also use Neutron, and when you're using OpenStack as a service, you can actually avail Neutron as NAAS, which is known as Network as Service. So this is what is Neutron. I'll be showing you how to make subnets, how to create your own network with the dashboard in a while. Till then, any questions? Okay, no questions. Okay, so next up we have Swift. Now Swift is the object storage system or object storage service in OpenStack. You can store all kinds of files, any kind of images or anything in Swift. So this is completely meant for storage. And in Swift, everything that you store is converted into an object, and then it is stored inside the database or inside the storage file system. And all the organizations are using Swift to store lots of data very safely, because it is very easy to retrieve data from Swift. And there are a lot of companies using Swift storage system to store all their files, like there's Comcast, there's Time Warner, there's Globo, Wikipedia, Rackspace, and a lot more other companies. You can read it yourself. Now let me show you the architecture of Swift. So in Swift architecture, we've got the Swift proxy, which is connected to each account, container, and object. So the account over here refers to a user account, whether it's a demo user or you are an admin user or any kind of tenant application user. So this is the account database. Now again, in order to validate it, you again have to go to Keystone for authentication and authorization. Then you can actually define containers to store your different objects, and the container database will store all kinds of metadata related to your files that you are storing in Swift. And like I told you, each of your files, whatever you store in your Swift storage system, it will be converted into an object, and this is where you can store all your objects. You can also store different objects in a container. You can define containers for storing as well. So this is the simple Swift architecture. Any questions on that? No questions? You guys are pretty smart. You're understanding everything that I'm saying. Good. So next up we've got Cinder. Now I really love the names of all the OpenStack services. I think they're really fancy. I love the name Cinder. I don't know why. Now Cinder is the OpenStack's block storage service. Now you might be asking me that what is the difference between Swift and Cinder? They are both meant for storage purpose, right? So actually a Cinder is a block storage system. It is more of like a pluggable storage system. Think of Cinder as an external hard disk that you can plug into your computer for accessing anything. And your Swift is the disk that is in your computer, in your local machine. So that is Swift and this is Cinder. And when you are actually storing objects in Swift, it gives you with a link. When you are actually storing your objects in Swift, what happens is that you just get a link for your object. You don't know where in the memory it is getting stored. When you're using Swift, you don't have to actually worry about how is your object getting stored, how is your memory getting managed. So you can all leave it up to the OpenStack service. They will take care of the memory management about how your objects are storing. But if by any chance or accidentally you lose that link, you actually lose your entire object. You cannot actually find it again in the memory. And in Cinder, the memory management is done by you. So this is very much similar to like the disk storage system in your computer, where you have a path defined for all your objects or all your files which are getting stored in Cinder. And let me tell you that with this block storage service, you can actually attach a device to only one instance. So you cannot use it with multiple instances. Okay, now let me show you the architecture of Cinder. So again, on the top we've got the APIs, because it's again a service of OpenStack and it will only communicate using APIs. Then we've got the Cinder scheduler. So what this Cinder scheduler does is that it schedules and routes requests to the appropriate volume service. So it might be, and depending upon your configurations, it can be either a round-robin scheduling or it can be any other scheduling. And depending upon your configuration, this may be something, it may be a very simple round-robin scheduling to run the volume, or it may be any other kind of scheduling depending upon your configurations. Now, the Cinder volume over here, it manages the block storage devices, and specifically they are the backend devices themselves. And the Cinder database over here will contain all the metadata about the files that are in your block storage system. And then we have the queuing system here again. So this is directly connected with the schedulers. Every time the API gets a call or any kind of request, it just comes to the queue part, and then the Cinder scheduler actually routes them to the Cinder volume, and then finally the Cinder volume stores them, all the metadata, into the database. So this is how Cinder works. Any questions? I think I'm gonna hear a no again. Is that right, Anirudh? Yes, of course. Like I said, no questions again. And finally, there is Horizon. Now Horizon is the dashboard. This is the dashboard which will actually help you to access all kinds of services like Nova, Swift, Keystone, and you can interact with all the services together using Horizon. So there's not much to tell about Horizon. It is pretty much about just showing you how to do that. So this is again the architecture. So the Horizon is the interface that is between all the different services in OpenStack and the users. So we've got this dashboard over here, Horizon, which is directly connected to the image service, which is Glance. It means that with Horizon you can directly go and launch instances. And in the instances, if you want to when you want to launch an instance, if you want to store something, if you're doing some kind of storage operations, if you want to store something, it will directly route you to OpenStack storage, which is Swift. You can also connect it with Cinder as well. And if you want to do some kind of processing in order to develop your applications or to test it or deploy it, any kind of processing required, you can use the compute zone of OpenStack, which is the OpenStack Nova. And all the APIs are connected with the different endpoints. So this is the Nova compute API endpoint, and this is the Swift storage API endpoint. And actually before logging on to Horizon, you have to get authenticated first. So I'll be showing you how to do that. So any questions on Horizon architecture? Okay, no questions. Okay, now let me just show you the dashboard and actually show you how you can avail all the services of OpenStack. Okay, so this is tristack.org and this is actually OpenStack sandbox that you can use. So they have installed all different services and you can avail all the services from this. So I'm going to log in with Facebook. I'm going to use my Facebook credentials. And so this is my Horizon dashboard. So you just saw that I just authenticated myself with my Facebook credentials. So this is the Keystone authentication part. Okay, so this actually helped me logged in into my dashboard. So I have made 2 instances already. So if you want to make more instances, so again here, this is the glance service. So if you've got different images already, let me just show you. These are all the images. Now this is actually the disk format that is supported by QEMU emulator, and it can expand dynamically and it supports copy on write. So these are all the images that I have here. So now let's say that I want to launch an instance. Let's say that I want to launch this zeros instance. So I'm going to just click here. So okay, I'll just name it compute. And then you have to add a network to it. So you can check the available networks from here, and if there are no available networks, so let me just show you. Okay, let me just first launch this instance and then show you that if there are no networks available, how can you actually create your own subnet to launch instances. So you can just click on launch over here. And so you can see that this is in the compute zone where it is created. This is launched over here. The status is active. The availability zone is Nova. The power state is running. And you can actually create snapshots if you're working on any kind of instances over here. You can create snapshots, and snapshots are nothing but it is the state of your disk at that particular moment. So if you want to preserve that, so you can actually create a snapshot of your instances as well. So I was telling you about how you can actually add networks, right? So you can just click on networks over here, and over here you can just go and create network. So you can just provide with any name. I'm just gonna provide, let's say it's Edureka, and just you can provide it with subnets and different subnet details. So I already have defined one network, so you can just do that if you don't have any. So I have got one network which is active and up and running, and this is your object store like I was telling you. This is the Swift part of the service. You can actually create containers over here. So there are no containers right now, so you can just create a container from this over here and you can store it. So now let me just go back and let me just tell you how to just access the instance that you have just created, right? So you can just go over here, which is the instances, and the volumes over here is actually your Cinder part of service. So it is not attached to, I have not included any kind of volumes with any kind of instances yet, so there is nothing to display over here. And let me go to the instances part, and this is the instance that we just launched. So this is over here. So the flavor over here is M1 tiny. So you can actually define flavors which are nothing but the size of your images, which are nothing but the size of your instances. So if you want to just access it, you can just go to their console, and it's over here. So you can log in as a Ceros user. And now this part is your authorization part where it asks for your user and password again. So if you want to access this VM or this instance over here, you need to get authorized first. And this is again done via Keystone. Okay, so now I'm going to just log in. It is asking for password, and there you are. You are just logged into your VM like that, and you can use it for any purpose that you want. If you want it to use for development purpose or any other purpose for your application, you can just use these kind of instances like this. So this is how you can actually avail an instance, and then you can also maintain the version by creating snapshots. You've got the Cinder service over here, which is volumes. The images is glance, access, and security is Keystone. Then we've got the Neutron as network. You can even check out the network topology. So there you have. So you have maintained your internal network. You've got 3 instances over here, and none of them are actually connected to the internet yet. So it's just for demo purpose that I'm showing you. So this is your OpenStack cloud over here, and I've got 3 instances. So you can get an overview of your entire network topology too. This is your Swift service, which is the object store. Your identity service is Keystone. So this is entirely contained. Yeah, so you can also see the name of your instances. So this is my first instance that I've created. This one was the second one, and this is the compute instance, and I've connected them with this network, which is named as network. So this is it. So this is how you can actually use the dashboard. So let us go back to our presentation now and move on with the next topic. So now let us take a look at a case study. Now we'll take a look at a case study of the Time Warner Cable and RV networks. So if you're living in US, you must have heard about Time Warner Cable. So this is one of the topmost cable companies in United States, and it earns a revenue of tens of billions of dollars every year. And then we've got the RV networks, which is the Time Warner Cable's OpenStack cloud provider. So let us take a look at the problems they were facing and how OpenStack actually helped to solve their problems. So you know that Time Warner Cable is a cable company, so they are using different ADCs, which are nothing but analog to digital converters. And they were using very traditional and conventional hardware before, and you know the problem with hardware is that they are not very flexible. You cannot actually tweak them into a completely different shape or a completely different way, because they are hardwares and they need to be configured in very different and specific ways. So they are not very flexible. So if they want a solution for a particular app, they would have to just buy a new hardware of different configurations itself. So it was actually taking up a lot of money. And then the open source solutions that are available in the market, they lacked all the advanced solutions, and it's not capable, or they were not capable of actually handling this kind of an enterprise level business problem. And it also lacked the advanced features that Time Warner Cable was actually looking for. And when they started using virtual ADCs, the orchestration, or to just lay out how each of the virtual ADCs will interact with each other, laying out of that plan or orchestrating it was actually very, very complex. So there was not a proper management system to maintain that orchestration. So it became very hard to find a solution for this problem. So what they wanted was that they wanted to build an OpenStack solution with fully automated provisioning and integration with automation tools at Time Warner Cable. So they wanted to divide up all the resources into 3 parts. The first one is compute. This is where all the processing will take place. The networking will take care of connecting each service and everything to the outer world as well as in the internal network as well. Then storage for storing any kind of metadata or all other related files. So, and this virtualization or these layer would be placed on their own standard hardware. So now this is again an example of an on-premises OpenStack infrastructure. So this is how RV Networks actually helped Time Warner Cable to apply or implement OpenStack. So these are the tenants, and the tenants are actually the application developers. Now at Time Warner Cable, they're using different kind of applications for different purposes. So the problem was that is that they would have to provision each tenant. For each application, everyone needed a different environment, a different dev environment, a different prod environment, and so it was very hard to provision them. But with OpenStack, it actually became very easy. I'll tell you how. And you already know how, because if, let's say that when you are using that Horizon dashboard, if you were any kind of an application developer, you can see how easily you can actually create your own instance using the CLI or the OpenStack dashboard, which is the OpenStack Horizon, and the REST APIs to communicate. So the application developers are using OpenStack dashboard, and it is actually controlled and centrally managed by the RV controller. And the Central Cloud's DevOps team manages the OpenStack cloud. So you don't have to even worry about managing your own cloud. There is an IT team, and they use the RV user interface, and they use REST APIs to communicate with the RV controller, which then communicates and handles the application developer request of launching instances and managing their environments. And then everything is connected with multiple data centers across different servers, and whether it's a private cloud, which is an OpenStack privately hosted cloud. So you can see that everything is managed. So this is the most top tier, you can say. This is where actually a user is getting instance, and that is managed centrally by the RV controller. They're maintaining a private cloud, and there is also an IT team to manage everything, to manage the RV controller as well. So the problem of provisioning and the problem of being your hardware very inflexible is gone, because on the top of your hardware you have got OpenStack that you can tweak in any way you want. You can actually modify it, and it's open source. You can even modify their own source code to let OpenStack do whatever you want it to do. So it's made a very flexible. They can actually now use different applications. They can develop multiple applications at once, and with OpenStack services like Heat, which is an orchestration service, you can also get rid of all the orchestration problems that was due to the virtual ADCs, and these are all managed by the RV controller, and RV controller is the OpenStack provider. So this is how they were managing all the different tasks and services in OpenStack. They were actually managing all the tasks by setting up an OpenStack infrastructure. And this is a very detailed flow of the next gen ADC and this was implemented by RV Networks on OpenStack Cloud. So these are the Nova instances of the application developers, and they're building up applications on these instances. So every other user are making different applications. So again, this is the RV controller, and it is availing all the services like Horizon, Nova, Keystone, Neutron, and LBAS, which is Load Balancer as Service. So with Horizon, it also provides you with visibility and analytics. You can actually visualize completely how your network is laid out, how many instances do you have. You can get all the data for analysis as well. And this is the AV controller cluster, which contains all the different Nova instances that is distributed among the different application developers or the different tenants. So any questions on this? I hope you've understood this. This is fairly simple. Okay, no questions? And so that was it. So we have learned the different cloud concepts. So we've learned what is infrastructure as service, platform as service, software as service. We have learned what is OpenStack and the different cloud deployment models that can be used to deploy OpenStack. We have seen the OpenStack architecture, the different OpenStack components and services, and in the end we have also seen a case study of the RV networks and how RV networks help Time Warner Cable to solve their problems using OpenStack Cloud. So thank you everyone for joining today's session, and if you have any questions you can get back to me at any time. If you still have questions you can ask me, or if you just want to give me any kind of feedback, or if you have any kind of queries left, you can actually comment down below. Thank you for watching this video, and I'll see you next time. Till then, happy learning.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!